Oh, hello. Thanks for joining me for the second part in our investigation of displacement reactions. First, we have to check your answers for the equations I asked you to try during the previous lesson. Here they are again. I asked you to complete the equations for iron reacting with copper 2 nitrate and lead reacting with copper 2 nitrate. Did you give it a try? Do you remember that we said that when a displacement reaction takes place, a solid metal dissolves and pushed out the metal in solution because it is more reactive? So, if the iron in this reaction displaces the copper from the copper 2 nitrate solution, the products of this reaction are iron 2 nitrate and copper. In this reaction, the products would be lead 2 nitrate and copper, because here the lead displaces the copper to form a new lead solution. Well done if you got this right. Do you remember what we discovered about the reactivity of the metals that we tested in our previous lesson? Let's refresh our memories. We found that copper was displaced from its solution by zinc, iron, and lead. Copper was the least reactive of the 4 metals tested. Zinc was the only metal to displace iron from a solution of iron 2 nitrate. Now we can continue with our experiments. Can you still remember which solutions we'll be testing with today? Yes, zinc nitrate and lead 2 nitrate. Here is what we would like to achieve by the end of this lesson. By the end of this lesson, you should be able to describe the reactions between solid lead, copper, zinc, and iron with a lead 2 nitrate solution and a zinc nitrate solution. Arrange the metals lead, copper, zinc, and iron from the most reactive to the least reactive in the reactivity series. Right, let's prepare our experiments. Like before, we pour the zinc into 4 separate test tubes. And add a piece of solid metal to each test tube. Remember to label the tubes so that we can remember which is which. I'm going to just set these aside and do exactly the same for the lead 2 nitrate solution. Looks like it's probably going to take a couple of minutes before we see any worthwhile results. Oh, looks like John's calling. Let's see what he has to say.
Diasha, I stopped you because I had an interesting idea. The reason that we're using nitrate salts is because they have a special property. They're all soluble. Sulfate salts, for example, wouldn't work. Lead sulfate is not soluble. It would give you bad results. So you have to use lead nitrate in these solutions. That's all I had to say. I'm sure your experiments will be ready by now. Bye.
Can you see how important it is to have the correct ingredients for each experiment to make sure you get the best results? Speaking of results, John's right. We should be able to observe the results from our experiments now. Remember to have your table handy to note the results down. You should remember that our zinc nitrate solution was clear and colorless. Let's see if this changed. There seems to be no change in any of the test tubes. The solution is still colorless and there are no changes in the appearance of the solid metals. What does this mean? Well, the most obvious conclusion that we can make is that no reaction took place in any of the test tubes. This means that none of the other metals are more reactive than zinc because they could not displace zinc from its salt solution. The last set of test tubes we prepared contains the lead-2 nitrate solution. Let's see if any reactions took place in these test tubes. Remember, lead-2 nitrate is also a colorless solution. In the first test tube where we placed copper into the solution, there is no change. But in the test tube containing the iron nail, we see that the solution turned a pale green color. The iron nail is also covered with a dark coating. The solution with the zinc has not changed, but has become murky because of the zinc powder. You should also be able to see that the zinc is covered with a similar dark substance. There is no change in the test tube containing the lead, but that is to be expected. I've put all of our results into a table. Let's analyze them together. We know that in a displacement reaction, a more reactive solid metal pushes out the metal in solution to form a new metal salt solution. The displaced metal is deposited as a solid metal. So this dark substance we saw must be solid lead, displaced during the reaction. Let's look at the equation for the reaction of lead and iron 2 nitrate. The word equation for this reaction is iron plus lead 2 nitrate react to form lead and iron 2 nitrate. So the chemical equation for this reaction is Fe plus PbNO32 react to form Pb plus FeNO32. If we count the atoms of each element on both sides of the equation, we see that this reaction is balanced. What do the results of our experiments today tell us about the reactivity series? Well, we have confirmed that zinc is the most reactive of the transition metals that we've used in experiments in this series. We also know that lead is more reactive than copper, but less reactive than iron. So our completed reactivity series so far looks like this: potassium, sodium, lithium, calcium, magnesium, zinc, iron, lead, and copper. As a task for this lesson, there is an experiment I would like you to ask your teacher to help you set up. Let's go to John and Seppo to see how it is done.
Seppo, we're doing a really interesting experiment. One that the viewers out there can try for themselves. We're making a silver nitrate solution, stirring it up, making sure it's all dissolved, and then into that I'm going to take some copper wire, clean it, and place it into the solution. For the best results, you need to keep this aside overnight. Seppo, would you please put this to one side for us? Now, can you answer the following questions based on the results of this experiment?
What do you observe on the copper wire? What does this tell you about the reactivity of silver and copper? Write a balanced chemical equation for the reaction.
Enjoy this experiment. We'll see you next lesson with the results.
The experiment that John just showed us is also called the silver tree experiment. Does that give you a clue as to what your results will be? That's the end of today's lesson. See you next time.